On June 23, 2025, Northrop Grumman carried out a significant test for the U.S. Missile Defense Agency by successfully launching a threat-representative ballistic missile target from a U.S. Air Force C-17 transport aircraft. This air launch marked a major milestone in missile defense testing, representing the first time a ballistic missile target of this kind was released mid-air from a heavy cargo aircraft and then ignited during free fall. The missile followed a planned trajectory and was tracked over a distance of approximately 2,000 kilometers, validating both the launch method and the tracking capabilities of advanced U.S. missile defense systems. The primary purpose of the test was to support the Long Range Discrimination Radar (LRDR) program, which plays a critical role in early detection, tracking, and classification of long-range missile threats. Located in Alaska, the LRDR is designed to distinguish between actual offensive threats and decoys or space debris, enabling faster and more accurate decisions during a missile attack. During this test, the radar system successfully engaged with the airborne launch target, confirming its operational capabilities in a realistic scenario. Northrop Grumman's air-launched ballistic missile target is part of a new generation of high-fidelity threat emulation systems. These targets are equipped with advanced avionics, modular vehicle enhancement kits, custom payloads, and solid rocket motors. They are built to closely replicate the performance, flight characteristics, and behavior of real-world ballistic threats, allowing missile defense systems to train against highly realistic scenarios. By launching from a C-17 aircraft mid-flight, the system offers unmatched flexibility in terms of geography and flight profile. It allows testing from a wider range of altitudes, launch angles, and speeds than traditional ground or sea-based systems. Compared to older ground-launched targets such as the Hera, or sea-launched platforms like the LV-2, the air-launched solution enables greater adaptability. Ground-based and naval platforms are limited by geography and infrastructure, whereas an aircraft-launched system can be deployed quickly from nearly any region, flying into air corridors that simulate potential threat vectors. This flexibility is crucial in an era where threats are becoming more dynamic and harder to predict, including missiles with complex, maneuverable, or hypersonic flight paths. Since 2011, Northrop Grumman has developed and delivered 26 missile target vehicles under the direction of the Missile Defense Agency and has participated in 11 missile defense flight tests. Over this period, the company has steadily refined its technology, focusing on precision guidance systems, ignition reliability, and modular design to improve performance and realism. Each vehicle is developed under the agency's Integrated Master Test Plan, which is tailored to replicate potential threat profiles from major global powers and technologically advanced adversaries. This latest air launch test is also strategically important. It supports the United States' broader goal of maintaining a credible, layered missile defense architecture. Systems like Ground-Based Midcourse Defense (GMD), Aegis Ballistic Missile Defense, Terminal High Altitude Area Defense (TOD), and the Patriot missile system rely on rigorous and adaptive testing to remain effective against evolving threats. By simulating non-traditional launch angles and variable threat behaviors, the air-launched system allows for more robust testing of these platforms, detection, tracking, and interception capabilities. Furthermore, the ability to simulate high-speed and quasi-ballistic or hypersonic trajectories addresses growing concerns over the proliferation of advanced missile technologies worldwide. As missile threats become faster and more agile, often flying lower or maneuvering unpredictably, defense systems must be tested against increasingly complex flight patterns. This test showed that the air-launched target system is capable of meeting those demands, offering both performance and flexibility. On the strategic level, the successful test reinforces the United States' commitment to modernizing and strengthening its missile defense infrastructure. It ensures that U.S. forces, as well as allied defense systems across Europe, the Pacific, and other regions, are prepared to face a wide spectrum of missile threats. In addition to improving homeland defense, this capability supports extended deterrence and mutual defense commitments to partners in increasingly contested global security environments. Northrop Grumman's work in developing and validating these air-launched missile targets is a crucial part of ensuring readiness and maintaining technological advantage. The June 2025 test not only demonstrated a significant leap in missile defense testing realism, but it also set the stage for more advanced trials involving future threat scenarios and next-generation missile defense systems. By enabling testing under more varied and realistic conditions, this capability directly contributes to the preparedness and effectiveness of U.S. defense infrastructure in a rapidly changing strategic environment.